So, hello everyone, welcome to the overview of process operations. We are working with the process life cycles, which are synchronous and asynchronous. The analogy of process operations is the multitasking operating system. We need an efficient way to execution of the process. For that, we need to create other processes and divide the problem into subproblems. Provide the efficient and fast execution. That's why we need that synchronous and asynchronous system calls. First is a fork system call. This is a system call used to create the processes. It takes no arguments and returns the process ID, that is the PID. Purpose of fork is to create a new process which becomes the child process of the caller. That is a parent. After a new child process is created, both processes will be execute new instruction following the fork system. In fork, that is return the negative value. The creation of the child process was unsuccessful. The fork returns 0 to the newly created child process, and the fork returns a positive value, the process ID, that is PID of the child process, to the parent if the returned PID is of the type of PIDT, which is defined as the header file sys types.h. Normally the process ID is an integer. Moreover, a process can function get PID to retrieve the process ID assigned to the process. This is the syntax for the fork system call. PID returns. Another one is a wait PID. So wait PID. Wait PID system will suspend the execution of the current process until one of its children terminates. The call wait and status is equivalent to the wait PID -1 comma and status status address comma 0. This is equivalent to wait of ampersand status. This is the syntax for wait PID, and the PID returns values. The PID values can be the -1 meaning wait for any child process, the 0 meaning the wait for any child process whose process group ID is equal to that calling process. Then less than -1 is meaning is the wait for any child process whose process group ID GID is equal to the absolute value of PID. Then is greater than 0 meaning that wait for the child whose process ID is equal to the value of the PID. Next one is the exit system call, which terminates the calling process. This is the syntax for the exit system calls. The exit int status. This is a return. Does not return any value.
This is the fork system call being used to execute a program. In this program, we actually create one child process and one parent process to explain how process operations and process execution will work with the help of fork. As we see in multitasking operating systems, fork is used to create child processes to execute a program really fast. So in this program, we are actually opening a file called test with file extension .c from gedit, and we are writing one program into that file, and later in the parent process we are actually opening a terminal to execute that program. So as you can see, after running the file, we can actually opening the test.c file in text editor, and we can write one program into it, and then we can execute that program into the another terminal by using the parent fork. So in this program, until we write the program in test.c, we cannot go for the execution. Once we are done in our writing and once we close that program, we can move further for execution of that particular program. So this is how we can use fork system call and other system calls to demonstrate how the process execution being operated into the operating system. Thank you.